Okay, so we want to derive the formula for this tetrahedron. So a tetrahedron, literally every one of these sides are equal in length. Okay, equal in length. So actually the angle, okay, between this edge here and the base plane with this edge and the base plane and this edge with the base plane, they're all going to equal. Okay, they're all going to equal. So everything about this is sort of a three-dimensional version of an equilateral triangle. Now imagine I cut a little thin slice down this way. So imagine if this was a cheese, right? So you can cut the cheese this way. Right, so you see a thin slice of an equilateral triangle? What would the next layer look like if I cut it again? Okay, so you can see that layer will also look like an equilateral triangle. Okay, so you can do that all the way down to the end. Okay, all the way down to the end. So we just need to get a function of that area. Okay, in terms of x. Okay, when I say x, let's set that length x to be this length here. So imagine there's a x-axis going through that way, like that. Okay, and we're integrating from, let's say, 0 to 0 to a. Sorry, 0 to, so that's not a. Sorry, if that's a, going like that, because the equilateral triangle, if that's a, this is going to be half of a. This length here, right there, is going to be okay. So let me actually show you. We cut an equilateral triangle in half. This is 1. This is half. This is going to be √3 over 2. So this is going to be √3 over 2a. Okay, so we're integrating from 0 to √3 over 2a. Okay, so from here to here, and so the next question is, if I know this length, so let's say I have an equilateral triangle. Let me just draw a fresh one. Okay, so if I know this length, let's call that y this time. What is the area of the triangle? If that's y, this right here, right? This right here is going to be y divided by √3. Okay, y divided by √3, and this is going to be 2y over √3. Okay, 2y over 3. And it's because the ratio between this and this is 1 to √3. Okay, so from this label, you can see that the base will be then 2y over √3. The height is y times by half. Okay, this is the area. This is the area. Okay, so we get a y squared over √3. So for this, in terms of x, it'll be x squared over √3. Okay, so that's the volume. If we integrate that from 0 to √3 over 2a, we get the volume. So let's integrate that. Again, the antiderivative of that is 1 over √3. It's going to be x cubed over 3. Okay, we're going to put √3 over 2a and 0. So that's 1 over 3 √3. Let's plug in √3 over 2a cubic in there. Minus, we plug in 0 in there, you just get a 0. Alright, so we get 1 over 3 √3. Cube that and you get 3 times √3. Cube that and you get 8. Okay, a cubed. Okay, so note that that just cancels out and we get 1 over 8 a cubed. Now if it was just a cubed, that's the volume of a cube, okay, a three-dimensional cube. So from here we just shown that the tetrahedron is exactly 1/8 of the cubed. Okay.